4 of pwn.college / ASU CSE Computer Systems Engineering 466. So let's get started. Actually, shit, I need to turn off the doorbell again somehow. Screw it. Okay. All right. Cool. All right, so we have ASU students on Zoom talking directly in my ear, the rest of the world on stream, but I need to connect up to Twitch so that we can all communicate with each other. Move some stuff around. Sorry about that. All right, as usual, if someone has questions, ask them either on Twitch or ideally verbally on Zoom, because the Zoom chat doesn't give me any notifications. So if you want to just, interrupt, please do so. All right, as usual, if someone has all right. The ding, still dinging. All right, hold on. Let me try to kill that ding on Zoom before, every time. All right, 1 sec. That ding. Okay. Meeting settings, play, join, and leave sound off. Perfect. Okay. Done. We're good. Okay. No more ding on Zoom. All right, we have already questions from what's it called, from Twitch. Who'd win in a fight, blue shirt Jan or purple shirt Jan? I don't know. It hasn't happened yet. All right. What else did I have to do? All right. I think we're gold. Let's roll. Okay. This is week 4. Today we're gonna undertake a new journey beyond source code. We'll leave source code behind. Actually, Connor, I just realized, did you make sure to leave source code behind for the new challenges? Oh, yes, of course you did. Perfect. Connor's on top of things. All right, first, we're going to do meme highlight for the week. So last week was jailbreaking. Hackers at ASU and around the world broke out of 14 levels of jails of various difficulties and various excitement levels. And there are a number of memes produced that I felt were pretty cool. One meme that's a little disturbing is that apparently people are not sleeping. Oh, no one can see my slides. There you go. The meme highlight. Let me vanish my video for a second so that you can see all the memes properly. All right. People aren't sleeping. They are instead... No, wait. That's the other way around. I misinterpreted that meme. Okay, good. People are sleeping. Awesome. All right. That's good. Then people aren't sleeping. This other meme. I really like this format. It's a good meme format. This is a good meme. One of the levels, of course, had a confusion between 64-bit and 32-bit syscalls, allowing a seccomp sandbox to be bypassed. So that was fun. And then this is what's coming. No more source code from here, likely on out to the rest of the course. We are shedding our dependence on source code. This one was great because it represented an actual problem that Connor and I experienced, where you crashed our server. So that wasn't very nice. Turns out there are certain things we weren't accounting for that we are now accounting for. When people started really hammering on level 12 to solve it, things went south. People suffered to get through all 14 levels, but plenty of people did, and it was very cool to see. And Adam and I, 2 weeks ago, Adam Dupay, a fellow professor and human being extraordinaire, suspected human being at ASU, we launched a podcast talking about capture the flag competitions. It's called CTF Radio with 3 O's. Turns out CTF Radio with 1 O is a 24/7 Christian TV internet worldwide program, leading to this great meme. If you're interested in CTF Radio, check it out on CTF Radio. CTF Radi.oo, RADI.oo. In retrospect, we could have probably chosen a less insane name. Anyways, look at our Twitter. We tweet the hell out of it. All right. Let's catch up on some questions. Could you place the Zoom link in the syllabus tab on Canvas? The Zoom link's on your My ASU, but I can do that. Yeah. I will write that down right now with an actual pen. Zoom. My pen's dead. Zoom on Canvas. Okay, pen is dead. That's fine. Maybe it'll be better with this. Zoom on Canvas. Awesome. All right. Cool. 14 question mark. Oh, sorry, not 14. 13. Wait, Connor, 13 levels or 14 levels? 13 levels. My bad. Yeah, Connor said in my ear the 14th flag was escaping the Docker container, but no one has accomplished that. As a reminder, if you find vulnerabilities in our system itself, there are bug bounties there for you. Someone linked me to a Discord, the CS Cafe. What happens if I click this? Oh, it's a CS Cafe. Oh, okay. No, I don't. Discord's screwing up. Anyways, I'll do that later. Awesome. All right. I die if I click it. Okay. Then let's catch up. On Twitch. Before we go into the topic, please share some info about the most crazy challenges you solved created. You'll have to wait for the podcast episode. People aren't sleeping. Yeah, that is unfortunate. You'll have to figure out a way to let people sleep. All right. There is a meme channel both in the ASU part of the Discord and the non-ASU part of the Discord. The ASU part of the Discord is much more active, but you have to be an ASU student. There's some good memes there, but I will share out the good memes at the meme review. All right. Let's roll onwards. CTF report this weekend. A bunch of students, 24 students played. I don't know why I said either Seesaw CTF. Copy paste there right there. 24 students from CSE 466 played Seesaw CTF for 1% extra credit in the whole course. The non-shellfish students. This slide is all messed up. This should be up here. So for in Seesaw, the non-shellfish students solved the union of 4 challenges, whereas the shellfish students, working together with shellfish team members at not just Arizona State University, but also UC Santa Barbara and UC Berkeley, won Seesaw. So that was incredible. They saw not only one, they solved every single challenge. There were 3 teams to do that. I'm super proud of them. Give them a big congrats in the channel. Yeah, awesome stuff. And there's congrats going in the Zoom chat. Great job. I actually have a clapper for this scenario. This is my high-tech soundboard for this stream, this class. So clap. So clap for shellfish. Awesome. Good job. Okay. Awesome. Let's roll. Okay. Actually, going forward, one change for the CTF write-ups is that there is now a strict 4-person minimum. you shouldn't be playing CTFs on your own when you're just starting out. It's lame, it's boring, you don't learn a lot, and it's annoying and it's frustrating. In order to earn extra credit from now on, you have to have 4 people playing, not just 4 people on your team. I need to get write-ups from 4 people that played that CTF with you, or 3 other people. Plan accordingly so that you always have a team, or find a bigger team, or find a different team. There's still a maximum of 8, but if, in order to ensure that the 4 minimum, that you can hit the 4 minimum, you accidentally hit the 9 maximum, or you accidentally pass the 8 maximum, it's okay. Very reasonable people, as you'll see. Write-ups, please don't copy and paste 1 write-up for every team member. People did that this time. We accepted it this week. We're not going to accept it next week. We're also behind on acknowledging the submissions. Don't worry, we have a bunch. Someone actually emailed me if we got theirs. I think we did. We'll expose that soon on the CTF on the CSE 466.pwn.college interface, so you can keep track. And please keep your writing quality high. I got 1 write-up that was like 3 sentences per challenge. I accepted it this week. Next week I will not accept write-ups like that. All right. Let's see if we got any questions on that. A moan. That wasn't a moan. I accidentally hit the fart button. This is a fart. Will the Great Tab update with extra credit? Yes. We just haven't had a chance to develop that yet. Yeah, don't write 3 words for 3 challenges. I will not accept this in the future. All right. Cool. Let's roll on. How are we doing in terms of ASU versus the world? The battle is raging. The world is encroaching. So now in the top 20, we have 1, 2, 3, 4, 5, 6, 7 hackers from around the world and 13 hackers from ASU. In order to get into the top 20, you still have to have solved everything. Of course, you can go back if you didn't solve one thing. You can go back and solve it to get back into the top of the world of the scoreboard for future assignments, of course. So you can still get those points on the scoreboard, and I'll talk about you can still get half of those points in terms of grades. Big upsets. Janitor Jeff, unfortunately, fell below 20th place. Whereas and Hollow Circuit, our old runner-up, fell to 9th place. The big winners are Flynn, who I think didn't even exist last week in the top 20. Took 1st place. Armistice took 2nd. Also didn't exist last week, I think. So that's pretty exciting stuff. And then we have Zero and Kriya, our 2 super elite people in from worldwide. And then O1 and FRQ mod zoomed up to 5th and 6th, and so on. I'm not going to read all 20. All right. Good job. That is an awesome battle. Let's see what happens next week. All right. Current grades. We started this class with 209 students registered at ASU. 140 remained. We lost 12 over this last week. And here on the top right, there's the distributions per homework. So baby Suid, this is A+, A, B, C, D, E. ASU doesn't have Fs, we have Es. Let me move my camera over here. This is the raw grades. So this is A+, A, B, C, D, E. As always, for some reason, we have this inverse of a bell curve. It's happened every year. I think people either really get it or they really suffer. I applied a small curve. If the class were to end today, there would be a small curve. That's why the curve clip art is mostly transparent. Very small curve, just to even out the middle ranks here. All right. I'm not gonna announce what that curve is right now because I don't want you to focus on that. Focus on something along the lines of I'll try to keep a flatter grade distribution if people are failing. This was a very, very small curve because a lot of people are right at that 50 something percent. All right, so if you are in this curve, or if you're toward the right side of this distribution, if you are suffering in the class, what to do? My advice: keep calm and keep pwning. Some people don't realize this, but if you solve a challenge after the deadline, it is still worth half points for your grade. It's still worth 4 full points for the scoreboard if you want to get to the top of the scoreboard. For your grade, it's still worth half points. So this means that if you solve only half of the challenges, if you only made it to level 7 or whatever, 6.5 this week, and then you go back after the deadline armed with new knowledge, new experiences, and solve the rest, you can still get a 75% in the class. Combined with extra credit for the CTF that I'll talk about later, that can get you an easy B. We have 2 weeks built into the class where there are no assignments. And during those 2 weeks, we'll run additional collaboration hours to help you catch up. All right. Again, one of those weeks is voting week. If you are eligible to vote in the US, please make sure that you're registered and that you do vote. It's very important to vote. That's why there's no homework on that week. If you don't vote, I don't know, I'll maybe assign homework on that week. But anyways, no, that week is makeup week. Question on Twitch: is the grade distribution only for people at ASU? Yes, that's only for the 140 remaining. Someone said that their bad grades are public good for the class. Let's see. Someone observed that solving old challenges while there are new challenges is, counterproductive. That's a good point, but there are 2 weeks dedicated to solving the old challenges, including the last week of the class, and I'll try to keep that open till the very last second where I have to submit grades. All right. Is there a plus minus grade scale? Yes, there is a plus minus. On the grade scale, I put the A plus here. Huge amounts of the class have an A plus, which is great. Traditionally, we have enormous amounts of A pluses in this course. As you can see, we give out the A pluses, we give out the A minuses, but here I just combine all the rest into just the letter grades. But like the last 2 percentage points of each grade will be the minuses. Awesome. All right. Someone observed you really need the fundamentals. Yes, the fundamentals are critical for this class. Will dropped students still count in the curve considerations? No, they will not. Awesome. Okay. Connor, people are talking about 19 flags. Did we launch Baby Rev already? Oh, okay. They're just memeing. All right, let's roll onwards. All right, I mentioned CTF extra credit. There's still 11% bonus remaining throughout the semester. There's 11 weekends in which you can play CTF for extra credit. As a reminder, you need at least 4 players on your team, at most 8. Unless you're playing with Shellfish, then you can play with Shellfish because I can actually go to their leadership and say, hey, did this person contribute? You have to spend either 8 hours at least, but hopefully you'll get hooked and spend your entire weekend, or you have to solve one non-trivial problem. And your write-up is individual write-ups highlighting your contributions. Question on Zoom: how do you go around finding a team? Post on Discord, ask on Discord, post on Canvas. And if you can't find a team, drop by, join Shellfish. The ASU club that flows into Shellfish is called the Pwn Devils. Go to pwndevils.com. They have a Discord link. All right. Someone mentioned, I don't think it's intellectually possible for me to solve a challenge working with shellfish. These are some really incredible hackers. They won Seesaw. It might be actually very, very hard to solve a challenge while working with them. I'd still recommend you join the Discord, chat with them, and maybe form a class-specific team on that Discord. You know, by seeing if people want to make a small team that plays without, you know, getting all of your solutions sniped by incredible hackers. All right. Awesome. Let's roll onwards. The course changelog. We're making one change to try to... actually, one thing I'll highlight on the Zoom that someone just said. While you might not be able to solve a challenge by yourself with shellfish, you can still work with players and understand how top players approach a problem. They're very friendly. They are happy to, you know, walk you through a solution. It's still very useful, and then eventually you start solving things. All right. The course changelog. We have a new collaboration policy. Before, we had just the collaboration hours, and past that, where people could work together as much on anything as they wanted. But of course, on the new challenges we launched, and we will have that still. We will be adding a help channel on Discord. One for ASU students, one for non-ASU students. The channel will always be active, and you can ask questions about underlying concepts. You can say, hey, what the hell is this file descriptor that you need for OpenAT? Stuff like that, right? And you can help each other. And we can help you. A nice central place for help. You can also post on Canvas. Same sort of policy for Canvas. Feel free to ask questions. Don't directly help people solve challenges, or don't directly tell people how to solve challenges. Help them to understand the underlying concepts. If you are interested in this as you're working together, or help each other understand an underlying concept. You can even, you know, for example, if you're saying, okay, well, I think that, you know, maybe we have to first make a directory and then pass it, you know, to chroot. That's fine on that level. But saying, okay, here's my shell code is not fine. Don't exchange code or flags, obviously. Do link to man pages, other documentation, talk about concepts, etc. If you overshare, there was a little bit of oversharing in the meme review. This meme was technically a pretty big hint on how to solve one challenge. No one got, you know, what's the term, expelled for that or anything. We're reasonable people. If you're not out there trying to cheat, we're not going to delete you. So don't freak out. Just everyone do your best in a reasonable way. All right. Can non-ASU people publish write-ups for extra credit for the hypothetical certificate? I don't know what the hypothetical certificate is. Are you talking about write-ups for CTF? Yes. Write-ups for these challenges, please don't. It's a course where people should be approaching these challenges. But for CTF, absolutely. If you want to write up a CTF, you're going to have... Don't email it to us yet. We're going to have a submission link for write-ups, and then we'll... that's where we'll be moving our write-ups. When that's ready, I'll announce it, and non-ASU people can also do it. You'll get like a flare on the scoreboard. All right, cool. Hopefully this will help people with that are struggling in the class. Let's see how it goes. Awesome. Other changelog. Here's where we are in the schedule, right? Today is binary reverse engineering, is the launch of it. Hopefully you've all seen the lectures already. There are 6 of them. I may have gotten us banned from Twitch by talking about game cheating, but hopefully not. then next week is memory corruption. And then we figured out what to do with the wildcard modules. Rather than exploring random topics, we're going to put all these concepts together with some more realistic exploitation scenarios. So the week after next, we'll have a number of levels that use all of the concepts that might require some might require the reverse engineering of some process running in a sandbox to use a memory corruption vulnerability in the parent process that it can talk to escape the sandbox by injecting shellcode into it to exploit something in a set UID process elsewhere in the system. Something along these lines. All right. It's going to be awesome. I think we're really excited about it. I'm really excited to see what you guys think of it. It's going to be awesome. People are very excited. I see someone saying hard pass on Twitch. I'm assuming because they will pass that module. All right. This is great. Someone hasn't left their hacking chair in days. That's the kind of dedication we like. Sometimes when you're super passionate about something, just time flows by, and you open your eyes, and it's next Wednesday, and you're watching a Twitch lecture. Awesome. All right. Now there are people explaining to me what a hard pass means. I'm not quite that old, but close. Okay. But in all seriousness, for those who are really struggling, hopefully this help channel will help. Yeah, it's gonna be good. Cool. Okay. Let's move on to the extended Q&A. First of all, the challenges are the baby jail deadline has passed. Anyone have questions on baby jail? No questions on baby jail? Can I demo my solve for 3? Absolutely, I can demo my solve for 3. Let's start with that, and then we'll roll on. And how would you solve 12? Brilliant questions. We'll do that, and then we will roll on to the reverse engineering. All right. For 3, let me go to pwn.college here. Connor, is our server dead? Is CTFD dead? I mean, I have internet access, but I don't have CTFD. All right, let's catch up on. Okay, someone asked. Okay, someone answered. Yeah, someone asked if this is a national college course. Yes, this is the Computer System Security course at Arizona State University. You see, we have this awesome logo on the top right. All right, what are we doing? Challenges. I think the server needs some help. Got a 502. All right. When in doubt, reboot. Do I have baby jail locally somewhere? No, I just have baby shell locally. Let me see if I have it. Actually, let me see if I have it somewhere else here. Damn. We'll wait for Connor to reboot the server. Server gets to go to sleep, but not the students. All right. Basically, the question... Oh, it's rebooted? Whew. Nice. All right, level 3. Let's launch it up. Run this. Actually, let's run it in practice mode. So we can sudo to explore. All right. Now we're going to SSH. Here we go. Let's run baby jail. Level 3 says the challenge will chroot into a jail and open a file. So before chrooting. So of course, let's try /flag. Well, obviously, it ensures that we're not trying to open the /flag. So let's just do etc pass wd just to open something, and then it reads in some shellcode, right? And if we strace it, we can see what it does. Does this open at for etc password, then it creates a jail directory, then it chroots into it. It creates a fake flag, and it memory maps some space for our shellcode, reads it in, and then it'll execute it. Of course, until now, the challenge source code was here. So we could do level 3 teaching 1.c. This is the shellcode exactly as we observed from that strace. Cool. So we need to write some shellcode that will do some good stuff for us. Let's do it. First, let me clone my shell tools. Oh, crap. One sec. Let me copy it in there. I don't know why I need the Git history, but whatever. How does this Git repository have so many things? Okay, let's SSH in. All right, now we can start writing some shellcode. Let's see what shellcode we have here. Just let's just do an exit. So we move 60 into RAX. Syscall, we'll do assemble. Okay, shellcode that does exit. Now we can cat shellcode.raw through, let's strace it. All right, with etc pass wd as the file that the sandbox will allow us to open outside of the jail. Cool. So it of course disassembles our shellcode and executes it. Let's actually turn off strace. So we can see here, this is the shellcode it's executing, and of course in the strace we can see that it exits with some random number because we didn't clear out RDI, but that's fine. So now we have the exit. All right, so now we can actually look at the source code. And someone asked me, several people asked me, how do you even approach these concepts, right? Well, what are the concepts on display here? The concept on display is that there was a chroot with a chdir, right? So it's the proper way of doing chroot. If you Google for chroot and chdir in combination, or if you watch my lectures, I talk extensively that when you chroot, you need to do chdir into slash to be correct. And before that, there's a previously opened resource from outside of the jail. So you Google for chroot previously open file, you can get a lot of discussion about how to escape chroot. One thing to keep in mind, there's two tricks to this. One trick is that Linux has a set of syscalls alongside open, exec, link, and so forth. So here's the open man page. We have the open syscall, which opens a file, and then we have open at, which opens a file relative to some previously open directory. All right. This takes a directory file descriptor. How do you get a directory file descriptor out of how do you just create one? Well, you can open a directory. It's very easy, right? So let's actually see if this works. Can I just do slash instead of slash /etc/pwd? And we can see it executed all the way to the end, so something hopefully worked. And here you can see it actually opened the directory slash. Boom. Now we have a directory file descriptor. Now the remaining challenge is open at. So what is the syscall for open at? Of course, we can look up Ryan A. Chapman, or we can use shell tools, look up syscall, open at 257. So if you take call open at with the file descriptor that got opened, it is returned an RAX from the open call. The path name that we want relative to this file descriptor, and the flags, read only, read write, write only, what mode, how we want to open it. We just want to open it in read only. So we're going to do shellcode.s. Am I going to delete this exit call? No. I highly recommend not doing it for this module, or any time that you have the luxury to exit cleanly. That way you can tell if your shellcode crashed or it finished executing and then crashed in data after that. So let's, what was it, 257? Yeah. Let's set this up. So this will call open at. Now we just need to set up everything else. So we need to give it a file path. And that file path, it was a relative path to that directory. So if the directory, by the way, you can also do directory of slash, anything here, right? You can do slash home, right? It opened that up just fine too. Where did it open it up? Just right here. Nice and simple. Cool. Okay. If we do, let's assume that we're going to do slash home. Where is the flag relative to slash home? The flag is in slash home slash dot dot slash flag. Of course, if you're in slash home, cd dot dot, you're in slash cat flag. Permission denied, but that's where the flag is. So let's just pretend to be interesting. Of course, it's much easier to just put slash here, and the relative path is then just flag. But if you're in slash home, it'd be dot dot slash flag. So let's do that. That's our path. We move RDI file descriptor 3 that we saw was returned for our open of slash home file descriptor 3. Cool. We move into RSI, not move. We load the effective address of rip plus path. We move RDX 0, that's the mode, that's read only. And then we do a syscall. Now we have hopefully an open file descriptor. Let's strace that. See, this strace does an open at. If we run that in the context of the challenge, we have an open at successful open. File descriptor 4. Very cool. Okay. Now we move file descriptor 4 as the first argument of as the second argument of send file. That is and oops, RAX. We move RDI standard output as the first argument, so we're going to write into standard output from the file descriptor returned to by open at. We're going to start from 0, write the beginning of that file, and we're going to write out 1024 bytes, and we're going to, what's the syscall number of send file? Thank you. Didn't want to have to look it up. All right. So here's our shellcode. It'll do open at, send file, exit. Let's assemble it. Open at, send file, exit. Of course, here, this doesn't fly because there's no such thing as .flag in my directory, right? But there will be relative to file. Oh, there's also no open file descriptor 3. But there will be relative to that when I do this. By strace. Here it goes. We do the open at, it succeeds. We do the send file, it succeeds. Here's the practice flag. It can succeed also without strace and sudo, as you can see, like this. There we go. One more thing. Let's now go back to pwn.college. Just click real mode instead of practice mode. Go back to the terminal. Log back in. Oh man, and it didn't save my history because I didn't cleanly log out. And just copy paste this. Here's the real flag. This is my flag, my unique flag. Don't submit this flag or we'll have to expel you for cheating. Get your own flag. That's how you do level 3. Cool. Questions on that? And we'll run through maybe 8. We'll look at 8 and 9 real quick. Let's wait for Twitch to catch up. No one on Zoom has questions. Are we still live? Connor, can you still see us on Twitch? Awesome. Can you show the shellcode you used one more time? Absolutely, man. It's very easy. In fact, I'll open it up and so here, what are we doing here? We are calling open at 3, which is our outside of the jail dir fd directory file descriptor, and then .flag, the flag relative to /home, and 0 for read only. Okay, here send file 1, the flag, and the 1024, and exit so we know things succeeded. Done. That's our shellcode. Also, this is all going to be recorded. It'll be on the VOD. Okay. Cool. Let's roll on and look at challenge 8. Challenge 8, teaching 1. Let's launch it in practice mode. All right. First, challenges, baby jail, level 8, teaching 1. All right. This is super jail. First we chroot and chdir into the jail properly. Say okay, then we create this fake flag. Then we read in the shellcode, disassemble it, and now we initialize a seccomp filter. You say by default kill everything that is not explicitly allowed. What it's allowed: open at, read, write, and send file. Okay, this sounds familiar. Open at, send file. We did that, right? We just did it. But there's a twist. In level 3, the challenge was nice enough to open up file descriptor 3 for you. Right here, we have no file descriptor 3. What happens if we cat shellcode.raw pipe through? Let's do an strace of this. Okay, there's no file descriptor 3. When we try to do an open at, we get bad file descriptor because we never opened file descriptor 3. That's a big bummer. And it might seem to you that you're screwed. But obviously 90-something people have solved this, so you're not screwed. Why are you not screwed? All right. Here's one thing that I posted in the errata. pwn.college/modules/sandbox. Scroll down, there's some hints and tips, and one says read this thoroughly, especially section 6.3.1. This is the bash manual for redirection of input output. You're very familiar with this, right? You can redirect output somewhere, and you can redirect standard error to standard output. This is directly modifying file descriptors. File descriptor 2 is standard error, file descriptor 1 is standard out. In the same way, you can redirect standard in with the a less than symbol. And 631 actually says, hey, by the way, redirection of input cause the file's name results from the expansion word to be open to reader on file descriptor n, or 0 if n is not specified. So when you do, let's switch back to the terminal. When you do, so one cool hack, you do proc self fd, you can see the file descriptors that are open by the process that's querying this. So this is the file descriptors that ls has opened, right? Here's file descriptor 0, file descriptor 1, file descriptor 2. So standard input is coming from my terminal. This is a pseudo terminal that is created by SSH when you connect up. File descriptor 1 is connected to my terminal, file descriptor 2 is connected to my terminal, and file descriptor 3 is opened to this directory that it's reading entries out of to list them here. Okay, what if we redirect standard input? So let's say, let's say echo hi, pipe through that, right? This is a very common way to redirect. Well, here it is. Standard input is some random pipe. Okay, that's interesting. What if we instead redirect this way from dev null into ls? Okay, here's file descriptor 0 is dev null. That's interesting. We can also redirect, as you can see, well, of course, we can redirect standard out. That's not good. Of course, we didn't see anything. We can redirect standard error. So what happened? Why didn't we see anything? Because it all went to dev null, and dev null just eats everything that you pipe to it as a special device file on your system. Interestingly, we can also put in arbitrary file descriptors here. So this opened up file descriptor 10 to dev null. Doesn't that give you an idea? We can also redirect this for input if you wanted. Again, 10 to dev null, but before it was opened in writable mode. because it was an output redirect. Now it's open in readable mode. It's an input redirect. I don't think that matters for this scenario, but we can also do this. Nothing's stopping you from sending redirection of a directory. In fact, you can redirect the directory even into standard and input. But of course, if you then try to read from it, bad stuff would happen. It's actually pretty funny. Here's the Python interpreter. If you redirect a directory into the Python interpreter standard input, it crashes. Even if it's not here. Let's just do hello.py. We print hi. Whoops, I have too much C. That was embarrassing. Okay, Python hello.py. There we go. Python hello.py with a standard input of a directory. Crash. Very annoying. It'll crash immediately. Okay, because standard input is a directory. I don't remember when this caused me issues, but it caused me issues. So, cool. Point is, we can send a directory into the process. So, as a reminder, this is what happened. We did an open add. There was no such file descriptor as 3. Well, what if we create one? Maybe this is an strace issue. Strace probably closes it. Interesting. Without strace? Boom. So what happened is we used the exact same shellcode as we used from level 3. Exactly the same. All we did was open up a lifeline out of the jail and redirect that to the thing. The challenge. Sorry, I only got 3 hours of sleep last night because we were getting the reversing challenges ready. But it's good. Okay. Let's see. We should... Connor, when do we need to start the collaboration hour? 6:15. Okay, so we have time for a couple more. So that was 7. There's also 12. Everyone's clamoring for 12, and someone asked about 13. Oh, someone says always use custom file descriptor of 254. Bash has, if you look at Bash's open file descriptors, it has like a crazy 255 file descriptor open to my terminal. We found this in office hours on Monday, and I don't think we figured out what it's for yet. Okay, cool. Let's look at 12. Let's launch it up in practice mode. All right, here we are. Oops. Level 12, teaching 1. Okay, this is a pretty tough one, right? So, level 8 dropped us in a jail with no open file, which is a bummer. But it gave us the tools to do what we needed to do. Level 12, on the face of it, seems to take away those tools. That's mean, right? What happens? Level 12 makes a seccomp policy that only allows us to read. That's it. How do you communicate out a flag only reading? That's crazy talk, right? So let's look at the rest of the challenge. Before it does this, it opens a file. Any file. It doesn't make sure it's not /flag. We can happily open the flag. So baby jail, if you do strace it, you can see it opens the flag just fine. So okay, that's easy. The flag is open. But now if you're in a jail, in seccomp, in a sandbox, and all we can do is read. So when, you know, if I try to, if I modify my shellcode.s, where's my shellcode.s? This does the open send file. We no longer need the open. We can just do send file, right? Let's see what happens. Assemble. Okay, this will now just do send file. Let's see what happens when we cat this. /flag. Bad system call. Oof. Why? Because we tried to execute send file, and all we could do was execute read. All right, let's not do send file then. Let's get rid of this. Let's do read the flag into the stack. Okay, so we'll move RDI. The first argument of read is 3. It's that file descriptor that was opened. RSI, RSP, pointer to the stack. So that's where we'll read to. RDX, the amount of things to read. And then RAX0, that's the syscall number for read. We do a syscall. All right, we can't do exit anymore. No more exit for us, unfortunately. Cool. So we do the read. Now we don't need the string. That's awesome. Now we assemble this and we run it. Of course, it crashes, but we didn't get the flag, obviously, because if we strace it, we can see we read the flag just fine. This is the flag in practice mode, but now it's on the stack. It's still not, hasn't gotten out to us. So what do we do? Seems pretty bad, right? Is my audio fine? People are saying weird things about audio. Yeah. Oh, really? Ah, interesting. Must be some Linux stuff. If everyone ran Linux, then this would be normalized and we wouldn't have this problem. You'd be used to randomly getting your ears invaded by very loud volume. Okay. So we're at a kind of a pickle here because we can't seemingly communicate out to the outside world. But what did I say in one of my lectures? Let me bring up these slides. In my Escaping SecComp lecture, actually, let's load it up as slides. Very important thing I said. All right. If you can't get data out easily, as long as you can send some sort of a signal to the outside world about data, you can get data out, right? As long as you can communicate one bit, you can run it, communicate the first bit, run your attack again, communicate the second bit, etc. In prior levels, you used sleep and the return value of exit for this quite successfully, probably to communicate a byte at a time, right? But now sleep and exit are both blocked off. That's pretty bad news. Can we communicate one bit? Obviously, the answer is yes. Almost 100 people solved this challenge. How? Well, I give you a hint. It's already happened. Last time I ran this shellcode, it seg faulted, right? So we run it like this. Seg fault. Another time I ran this shellcode, if we just scroll up, it ran a bad system call. Try to execute exit or send file or whatever we were trying to do here. That's 1 bit. Did it exit or did it do a bad system call? In fact, you can do one more interesting thing. You can do a loop. Boom. That doesn't return for obvious reasons. It reads in the flag and then it hangs. Another signal. Does it hang or does it not hang? So, what can we do? We read in the flag. We want to communicate 1 bit. We can communicate 1 bit. Actually, we can communicate 1.5 bits. We can have 3 different signals we can send. Either crashing, bad system call, or sleeping. Or an infinite loop. So what we do is, one byte at a time, we move, let's say, into, so on the stack is where our flag is. We move some sort of a bit mask. So let's say we want to just examine the first byte, or the first bit. So this is a mask of, this, the value of this byte is 1, 0, 0, 0, 0, 0, 0, 0. Then we can AND that with RSP. We can move 0 out something, let's say RCX, so we're not interfering with anything. Move, let's actually do, this is simpler. Let's read 1 byte of the flag. So we read in the whole flag onto our stack. We can read 1 into 1 byte into CL, right? Okay. We can move our bit mask into RBX. We can AND RCX RBX. So this, we had 1 byte of our flag in RCX. Then we AND it, and I'll run through all of this in GDB so that we can see what's going on. We AND it to see, is this bit set? This does a bitwise AND on the binary level. And then we can test if RCX is 0. And if it is 0, we jump to the loop. Otherwise, we do something that'll almost certainly crash the program. This will return to some garbage that we just wrote onto the stack, right? Or you can, of course, do a memory, invalid memory access, and this will segfault. Okay, let's see if this assembles. I'm sure there's some issues. Nope. Okay. So here's our crazy shellcode. Let's give it a try. It hung. What does that mean? This means that it was 0. The first bit was 0. So let's find a 1 bit, and then I will show you what to do. So we have the first bit is 0. Let's look at the second bit. How do we get the second bit? We just shift CL to the left by 1 bit, and this will help us test the second bit. Boom, segfault. So the second bit is 1. We know that the first byte of the flag is P, because it starts with pwn.college, right? If we look at what P is in ASCII, lowercase p, OX70, that is 0, 1, 1, 1 on the first 4 bits. So let's check the next bit, the third bit. Oops, I didn't assemble it. Boom, it's 1 as well. Okay, let's see what happens when we in GDB when we check out the first bit. All right. So we'll do GDB baby jail. We can break at here. We run. Okay, we have trouble inserting a breakpoint because the location of the shellcode isn't mapped until it does the memory map. I can set a breakpoint at the memory map and then set, walk step instruction from there. It's much easier to set a breakpoint in your shellcode when you're ready. So this will drop me into a breakpoint in GDB. Assemble this. GDB, run. Oops. Run with /flag and the input of my shellcode.raw. Yes. Boom. Drop me into my own breakpoint that I inserted into my shellcode. So what did I just do? Let's enable a display of some instructions. So here we're about to do this XOR RCX, RCX, and so on. So far, we did this read. So let's look at the stack. Read errored out. Oh, sudo GDB. Of course, when you run GDB, it ignores the set UID bit. So now we can run /flag with our shellcode.raw. Cool. Here we go. Just 5i rip. All right. Oh no. Set assembly flavor Intel. Dash flavor. Okay, I'm sorry you had to see those AMD 64 instruction. Sorry, the AT&T syntax instructions. This should hopefully be a lot nicer. Okay, anyways, what are we about to do? We just read the flag. Here it is. It's on the stack. We're about to XOR RCX, right? Here it is. Then we are about to read the first byte of the flag. OX70. Awesome. Then you shift the byte by 1 to the left so that that second bit becomes the first bit, right? All right, now the first bit is set. Now we're about to move OX80 into RBX. Okay, and then so RBX is this and RCX is our shifted byte. Now we do the bitwise AND. Just 1 byte left, OX80. We test it. Of course, this test will tell us it's not 0. So JE and JZ are identical. If it doesn't make sense, why? Rewatch my assembly fundamentals lecture. And then this will jump us into, will not jump us to the loop, and instead it will segfault right here. Yeah, segfault right here. Cool. Another way, for me, it's easier to think of it in terms of shifting for some reason. Another thing you can do, instead of shifting this, you can change which bit is 1 in the mask. That might be easier for you, actually. So this is the leftmost bit of the byte, the most significant bit, second most significant bit, third most significant bit, fourth most significant bit, fifth most significant bit, sixth most significant bit, seventh most significant bit, least significant bit. And by changing those and rerunning it, you can leak out different bits of the first byte. For the second byte, add 1 here. That's the second byte now, and so on. Very straightforward. It's a pain because you have to run it a ton, but it works great. Oh my God, Twitch stopped streaming. Yikes. No, sorry, Twitch is streaming, but it stopped scrolling for me. So I missed a bunch. Have you been keeping up with the Twitch questions? Nice. Connor is memeing. Good. Okay, very straightforward. Awesome. I'm glad that it was good. All right, now get the flag. Of course, you can script this now and use it to get the flag. That I'll leave it an exercise to the reader, but it's, I mean, you see how, you know, just by modifying this and this, you can just continuously leak out different bits. All right, cool. Someone saying, just do it manually. You can do it manually. We have considered in the past making like 70 different variants of this challenge, so to force you to automate. But seems like a mean thing. Cool. Okay. Someone mentions you can also compare to an integer. You don't have to do this. You can do it a different way. You read in the byte, and then you say compare CL to 0, or let's say OX70. What's going on here? OX70, and then jump if it's equal. Then you just cycle this through every possible value of a byte, all 256. You execute this more times, but your shellcode's a little simpler. So you can do it many ways. There are many ways to utilize a side channel. All right. Someone's asking, are there any good resources for going more in depth to utilizing side channels? I don't know of any. We kind of did this as part of the jail, because oftentimes this is a way to get information out of a sandbox. I don't know if there's any sort of courses on side channel vulnerability specifically. Someone mentions, yeah, we can't do 70 of the same challenge. We devalued other challenges. So that's a good point. Someone's asking, how big of a difference does pwn tools make? Use pwn tools. It's the right way to do these things. You can launch the process, send input to it. In this case, it's not actually that much, So here, for example, I can do this in Bash. Do byte offset, and then I can do bit mask. Okay, this seems weird. Obviously, this is not valid assembly, but if I cat shellcode.s and eval it. Fuck, this doesn't have my bash key bindings. Better. This is going to be better. If I cat this out. Okay. And I pass in the byte offset and bit offset. So here, I now created a shell script out of my shellcode. So let's move shellcode.s into shellcode.sh. When I run this, it prints out my shellcode. You can see the byte offset and the mask disappeared because those are now variables. So I can do, let's just make them much easier. Shellcode.sh. First argument is the byte. Second argument is the byte mask. So I can do byte 1, byte mask OX80, boom. Can do byte 1, OX40, byte 2, OX80. And now I can do 4 I in from 0 to, let's say, 255. For J in OX80, OX40, OX20, OX10, OX08, OX04, OX02, OX01, do the shellcode of IJ, done, and done again. Oh, I need multiple do's here. This is a nested for loop written in Bash, and here you can see it's generating assembly for all of the different bit offsets of all of the different bytes. And all that's left is to generate this into shellcode.s, then assemble -c just prints it out to the command line, and pipe it to baby jail /flag. And here you can see it is crashing on, oops, my breakpoint trap. Let's take out this in 3. It's I need to run it with a timeout because I used the timing side channel. Timeout with 1 second. And here we go. You can see it is. Do we have a bad system call anywhere? Hold on. Let's, instead of the timing, shit. Okay. Oh. Yeah, we have the segmentation fault. So let's stop for user input. So here's 1 bit, boom. So you have 0, 1, 1, 1, 0, 0, 0, 0, 0. This makes sense. The first byte is OX70. 1, 1, 1, 0, 1, 1, 0. Do you see? How cool is that? We can automate it a little further, put that into dev null, and instead just echo the return code because it's going to differ. Should go away, go away. We can, well, why is it printing stuff out? Oh, dev null. See, different return codes. Ignore that segmentation fault. But the return code, this return code means 0, this return code means 1. We can time out much faster than 1 second, 0.5. So let's redirect all of that into a file. And we'll let it go a little bit, and then I'll parse that out into binary. Okay, this is probably enough to get the beginning of the flag. Let's kill this. All right, so now we have our outputs. Okay, we're gonna delete all new lines, and we're going to use sed to replace 124 with a 0, and replace 139 with a 1. Globally. Okay, this is the bit string. Let's hop into IPython. Let's check how many bits we have, because it might not be a multiple of 8. We need a multiple of 8. We needed 1 more bit. That's a bummer. There we go. That's 11 bytes. That should be enough to get something. Here it is. Here's the number representing that binary number. We can change it to hex. Okay, this looks like printable stuff, right? Now we can do bytes from hex that. What? Am I a noob? Oh, I see. Ah? What do you think? Awesome. Obviously, the more we wait here, the more data we get. It's not, you know, a ton of data. It's a little slow, but it works. Cool. Okay. Ha. You have to be careful when running this stuff. This means that the shellcode memory map failed for some reason. So if you see that, you'd have to restart because now I'm missing a bit. So that happens. Okay. Cool. Someone on Twitch mentions this is a lot simpler. It's a very small, minimal example of a side channel attack. Absolutely. In the real world, first of all, this timing is very hard to come by, right? We have a project going on in the lab right now where we're measuring timing differences on the order of nanoseconds, which is very, very difficult if you're, remote with network latency and so forth. Someone asked me, how did I modify the assembly? I'm glad you asked. I created a shellcode.sh file. This is a shell script. Let's look at it with syntax highlighting. This is a special syntax in Bash. It's called a here document. And basically it says, until there's a line that only contains the word end, send all of this as input to cat. And of course, cat just outputs whatever you put into it. So it cats it all out. And then I put bash variables here that are replaced with whatever I pass in to this script. So to the script, I pass in the byte offset and the bit offset. And for that, I have this insane nested for loop that I'm ashamed of exposing you to. The correct way to do this is using pwn tools. You can do all of this with pwn.asm to assemble your shellcode and Python functionality to do reasonable sane looping. Yeah, so someone's saying they did this manually, edited their assembly and so forth. Someone on the Zoom is saying that this knowledge is kind of extreme for this class with kind of ASU's prerequisites in the curriculum. It's some of these challenges are tricky, right? Getting a 100% in this class is going to be hard without the extra credit. You can still go back and get this challenge, follow this exact thing, and get half of the points for it. So instead of 100, you have 98 or something in the class. Yeah, someone said it would be cool to see how to do this in pwn tools. Connor, you did some pwn tools demos in your office hours, right? Does it touch on this? Yeah, so Connor's office hours from yesterday touched on this. So you can see him on Twitch or YouTube. Cool. Let's see. You can use editors like said. Oh, what is the shell tools? Okay, what is the shell tools? So I love shell coding. It's my favorite genre of hacking, let's say. And until this iteration of this course, I had this script that laying around called mksh that I could just that turned into this that I could pass some shell code and it would assemble it and like move rex60 syscall or a file name as you saw, and it'll assemble it and then do all the analysis on it, strace, check if there's questionable bytes, output it in different formats so I could paste it into scripts. And then I added this recently. You can do -C and it'll actually just print it out so that you can just pipe it into things. This semester I got this into, along with some other scripts, into a repository called Shell Tools. Here it's got a couple scripts. One script lets you look up syscall numbers or look up the syscalls associated with certain numbers. One script assembles, another script disassembles. It's a simple thing. Again, that works for me because I like doing things my own silly way sometimes. I would recommend instead learning pwn tools. All right. Cool. All right. Awesome stuff. Let's move on to reverse engineering. Oh, one person asked about 13. Let me just talk about 13. I'm not going to do 13 right on the spot. Actually, I have a one-liner I could paste. Anyways, let's just look at 13. So what is level 13? Level 13 is a crazy thing that we wrote. This is an actual sandbox that has a sandbox process inside it, right? So what happens? The challenge starts up, closes all the unexpected file descriptors so that you can't redirect stuff into it to bypass the challenge, and creates a socket pair that the parent and child will communicate. You can call this socket pair call. This creates two sockets. When you write data into one, it comes out the other, and vice versa. This is a very common way of communicating between a parent and a child. And that's exactly what happens here. Basically, we test. I wrote this not to test that the socket works. Of course, the socket works. It's a functionality of the Linux kernel. I wrote this so that you can see how the socket works. And then we fork. We fork into a parent and a child. And the child closes itself off from the outside world and only has the child socket open. Then it reads in shellcode over the child socket, which the parent provides to it, and executes it. Executes it under a sandbox that only lets it read, write, and exit. Okay? And then the parent sits around and listens for commands from the child and executes those commands. Now, this isn't necessarily a security problem. This is a sandbox understanding problem, right? We wrote this to simulate like the Chrome sandbox in a very, 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 very small way, where there's a parent process that listens for requests from the child and carries them out. And in this case, there was a request called read file. So if you wrote onto the child socket, read file, and then the file name, read file : and then the file name, it would open that file, read in the contents and send them back to you. And then you add another command, print message, that you could send back to the parent with the contents of the file that the parent had just sent you to print the file. Cool. Some memes about this in the Twitch. The Zoom is silent. Okay. Someone says, not so much about retrieving the flag, but what's stopping the processes from racing? Does the child wait for the parent? No, the child doesn't wait for the parent. The child just runs your shellcode and then does this exit 0, but in reality it crashes with a bad, or no, it exits. The child just exits. The parent doesn't clean up until after the child until this cleanup call occurs. The cleanup call occurs to handle a signal an alarm signal that is sent after 1 second. I did this to minimize the impact of side channels from the parent, or from within the child out, bypassing the parent. All right, someone says, what tools are we allowed to use for reverse engineering? You're allowed to use anything. We support Binary Ninja automatically by clicking. On that note, let's move on to the binary reverse engineering thing. Okay. Binary reverse engineering. So, Connor, are the challenges up? Connor's making challenges up. So if we go to pwn.college. Oh, wait. No, our practice problems challenges. Wait, that's the wrong browser. It's confusing. Here we go. Baby Rev is up. These are the first 10 levels of Baby Rev. There will be more tonight. Hopefully this keeps you busy for a while. Baby Rev is a crazy reversing race. No source code available. You open up Baby Rev and you suffer, right? So how do you approach this? You click level 1, teaching 1. You can, of course, hit up the practice. Let me show to you that there is no source code for Baby Rev. Connor, I think the server is getting destroyed. Okay, all right. We'll pause that. I'll notice one thing. This button, the inspect challenge button, if you click it, incredible things happen. A new tab opens with Binary Ninja. Boom. This is the least friction we could create for you to start reverse engineering. You literally open this up, click inspect, and it opens Binary Ninja. All right. You need to have a Binary Ninja account. That's free. Just sign up. Or you can use Ghidra, or you can use Anger Management, or you can use IDA Pro, or IDA Home, or whatever. IDA's Community Edition. But this way you don't have to install anything. I'm not advocating for Binary Ninja over any other favorite tools. I'm just saying that in the past, students have suffered with installing, configuring, blah, blah, blah. You don't have to do that. You can just use this. So you drop in, and then you start seeing right away the binary from start, right? So this is level 1, teaching 1. Okay, pro tip. To see what's going on, it might be easier to run level 1, teaching 1, because it talks to you. In fact, this finally started up, so here we are. So you can do Baby Rev, and then it'll say, okay, this license verifier will allow you to read the flag. Challenge takes input as a command line argument. It'll access argv1. As you know, the command line argument, command line arguments. As you know, argv1 is the first command line argument. I fucked up in my lecture. I apologize. This is what happens when you sleep an average of like 4 hours a day for the whole semester. Let me bring up the lecture real quick that I screwed up and show you the fix. It was in the functions and frames lecture. And I had this hilarious mistake. We actually used a program hello world, and I had argv 0 and 1 that pointed to hello and world. This is horrifically wrong and embarrassingly wrong. I have been waiting to make an embarrassing mistake on record for a long time, and now it has happened. My first embarrassing mistake of my life. Let me show you when I refresh what the new slides look like. Boom. Fixed. argv 0 is the name of the program. Or specifically, this is wrong again. God damn it. Let me fix it so that you can see the correct thing. I swear I'm not such a giant noob, but that's what you get. Okay. All right. Now it is really, truly 1,000,000% fixed, completely accurate. All right. Rip me. Okay. Here we go. Okay. This is the exact invocation of the program. This might be important, by the way. Keep that in mind. argv0 is how this program was run. Since we did /program, we actually did the program in the current directory. It's /program. If we had done /program, it's /program. If the program was in our path and we just did program, it would just be program. This, in fact, if you recall, one of the lectures we used a BusyBox in CH root jails. This is how BusyBox figures out how you're invoking it. All right. argv0 is the program, and then argv1 is the first argument, argv2 is the second argument. And then the environment variables are the environment variables. Very awesome. Okay, let's go back. Question of, is the command stored with a null terminator? Yes. All those strings on the stack are stored with a null terminator. Nubian guarantees it. Cool. Where are we? Okay, let's go back to... No. Yes. No. We're going back here. All right. So in argv1, we get the command. All right. Baby ref teaching 1. argv1, we try 1, 2, 3, 4. And it says the data that it was read in, 3, 1, 3, 2, 3, 3. And that is 1, 2, 3 in ASCII. So it seems to only read 3 bytes. The mangling, there is no mangling apparently. This is a license key verifier, like I talked about in the lectures. There's no mangling, and to verify, the program will compare it against 64, 63, 66. So let's try. This is a bashism. 64, 63, 66. That will get you the flag. Okay. This is, of course, normal ASCII. 64 is D, C, and F. Boom. Okay. Brilliant. So, what now? What now is to look at the testing one. So the teaching one guided us through that quite well. Very nice of it. Thank you, teaching. How does this help us on testing? This is going to be the first module where the teaching and the testing challenges are radically different. Teaching will help, but it won't. Your solution will be similar, but not exactly the same. So if we run the testing one, let's run it in practice mode. Okay, go, SSH in. Man, Connor, why does my mic go crazy? It makes no sense. Linux is perfect. Yes, everyone's challenges are slightly different. This is also the beginning of our challenge randomization of the course. So my challenge had DCF. Your challenge will likely have something else, or likely have different manglers in later levels. All right. So here we are on testing one, right? So I launch it. Of course, it takes an argument over argv, ASDF. No flag for you. I do DCF. No flag for you. It also doesn't tell me what it should have been. Now I need to figure out what it should have been. In my reverse engineering lecture, I say, before you dig in with Binary Ninja or Anger Management or IdaPro or Ghidra or whatever you dig in with, right? We can dig into this. We can go to main and we can reverse engineer this. And some people have said, look, you can decompile instead of disassembling. And nope, that's the wrong thing I meant to do. Yeah. Where the hell? Where's my scroll bar? Okay, fine. There, you can decompile and so forth. I would recommend you to get comfortable reading assembly, but it is up to you. So the point is, you can go through and you can reverse this and stare at it until you solve it, or you can do yourself a favor and see what it's doing dynamically. Ltrace, again, in practice mode. I'm in practice mode, right? I have sudo. Yep. So if I strace baby rev, these are the syscalls it's doing. I do ASDF. Okay. It says checking the license key. No, wrong license key. Of course, it's not using syscalls to check the license key, but it might be using library functions. Ltrace. Connor, is Ltrace broken on here? Yes. Okay, that's fine. No, not a problem. We just copied off into our own Linux box and use Ltrace this way. Now what? Is my Ltrace broken too? Ltrace is so unreliable. I am running in practice mode. Someone on Zoom talked about running in practice mode. Which Ltrace do I have installed? This looks reasonable. Okay, let's Google for this real quick. Ltrace not working, MD64. I run into this every once in a while and I never remember how I fix it. Okay, now I vaguely... Connor, I think we screwed up compiling this stuff. I think there's railroad settings that are incompatible with Ltrace. Yeah. All right. Well, there goes that demo. Let's switch back to if you can get Ltrace running on these, you can do good things. But let's switch to looking at the disassembly. So we look at, disassembly here. Let's make it bigger. All right. Here's all of our prints. And somewhere here it says, all right, to verify checking the received license key. Then it moves from this expected result into RCX. If we follow that, we see the expected result is OX2008. Okay. And what did I open? This is level 1 testing one. Oh, hold on. What's going on? I'm obviously not very adept at binary ninja. Okay. Go back here. Okay. So it ends up calling stern comp. This compares a string up to n bytes with the first argument being what seems like our flag. Let's see where our flag is read in. So we puts, and then we call receive your license. Let's just check argc var 14. No, that's 0. Okay. So stern comp gets 2 arguments. One is the okay. Let's, gosh darn it. Obviously, I normally use either pro. Connor, do you know what this rel? This is relative to the. And why is it 2008? It might be 2008. That might be the expected result. But yeah. I get that. But 08. Okay. Let's log in. It should be ASCII. Okay. What if we say 20 or well, let's do 2008. No flag, but it should be in little endian. 0820. No. Is Binary Ninja failing us, or am I a complete noob? Where's main? There's main. All right. So if you're looking, okay, it says mangling is done. To make things more complicated, it'll mangle. It doesn't actually look like it mangles everything, right? Anything. Or maybe it does. Oh, okay. We're looking at the teaching one, first of all. Let's not look at the teaching one. Let's look at the testing one. Let's go to main. Much easier to look at. I was wondering why all those prints were showing up. All right. So the teaching, it's much easier to interact with, but the testing is much easier to actually analyze. Right, so there's that trade-off because the testing doesn't have all of this debug code for you. So basically it says, okay, ready to receive your license key. It checks if argc is greater than 1, because otherwise it says argc greater than 1 failed. So this must be argc. It compares it with 1. It compares it and jumps. If it's greater, jumps to the actual challenge code. So we can rename this argc. Very cool. So now we know where argc is. Let's dig in to this challenge, checking the license key. So first of all, it does some mem copy of something somewhere, writes this, and then it takes the expected result, loads it into RAX, loads it into RCX, loads something else, another variable of the stack, RBP minus OXC, loads that into RAX, moves into EDX3, moves RCX into RSI, RAX into RDI. RAX, so this is Sturgeon comp, the first argument, second argument, third argument. So it compares 3 bytes. So now we know how long the flag is. The first argument to Stern comp is comes from RAX, which came from someplace on the stack. So this variable represents first Stern comp arg, and this variable is the second stern comp arg, because there's RCX, and then the way, if you click on RCX, oops, if you click on RCX, you can see that it got highlighted here. This is where it was written, or used last, written to specifically. It was written to by moving the contents of this relative address of expected result. Of course, this is our second stern comp arg. Okay, and then we basically compared one to the other. Okay, this is a pointer. Okay, this makes sense. It loads the address of this. Why does it move this guy, Connor? That doesn't make any sense. There's a pointer in here. At runtime, it must be relocated. Wow, okay, so check it out. This says OX2008. This represents something in the binary, actually. At 2008, we have the following data. 6F, 6974. Connor, how did we compile these things? We might want to change that. Did you see what it did? So this programmer did something insane. There's a relocation, which I don't think I even talked about in my ELF fundamentals. So we're gonna play around with the compilation arguments, and this code, and might actually update it. So what I did here, there's a load of this argument of this data from the ELF header, or not the ELF header, from the ELF some ELF section, either read-only data or data or one of those two, and then this is used as a pointer. How is it a pointer? If you look at it, the value of it is where did it go? Okay, Binary Ninja is just a little bit rough around the edges here. No, it could have changed, but the location of it wouldn't change. Oh, it's a car star. Yeah, we should make it a char array, not a char star. That'll fix this issue. All right, so if we look here, this second stern comp arg, unfortunately, yeah, here it is. It's OX2008. When this is loaded, this location is actually updated with the base address of the binary. Let me show you what I mean in GDB. It's annoying to have to do this, but all right. Let's just start. So now we've braked in main. If we do info proc map, here's our binary. If we look at the pointer value at the binary plus OX2008, that is not a pointer. Oops. Yeah, that's not a pointer. Oh, sorry. I'm looking at the wrong place. It's not at 208. That's at 4010. There we go. This is that expected result that Binary Ninja was talking about. That is a pointer to some crazy thing that ends in 008. If I print out this minus the base address of the binary, no. Where did this even fucking come from? If I print out this value, I get this 2008. So what happens is when the... Connor, can we just regenerate these challenges real quick? This is a little bit of a... I think it's worth it. Let's start in. We'll start the collaboration hour, and people should hopefully be able to follow along, and then we'll update those challenges. All right, so what happens is when the loader loads this, it updates this guy. This is a relative pointer, basically, within the ELF to a different part of the ELF where the read-only data is stored. And it updates this guy with the address of the ELF in memory so that it is actually pointing to valid data. All right, that really threw me off. Sorry about that. The nice thing now, so now that this is updated, we can look at it and see the strings that it needs, OIT, in the same way that if we scroll up this 2008 within the ELF at 2008, here is OIT. And you can see this is the hex and this is the ASCII. So let's, oops, you did not see that because I didn't switch into it. Here's that 2004, and then we dig 4 bytes in, and that 208 is this 6F6974, which is OIT. Okay. If we log out of here and we do OIT, there's our flag. Amazing. Okay. Someone asked, is the dash in GDB a subtraction or a range? This is a subtraction. Prints out this expression, the result of this expression. The /x makes it printed out in hex. This is very nice to do, little calculations. Okay, so this is a little bit of a harder challenge than we wanted. We're going to regenerate this challenge. The flags won't change, but we'll let you know when new binaries are generated. In the meantime, let's jump into the collaboration hour. We'll keep it rolling until 7:30 and collaborate on solving some things. And let me unlock the collaboration rooms. Can I explain the what now? Yes, I'll run. Let me open the rooms and then I will run it through one more time. Okay. ASU collaboration rooms are open. Global collaboration rooms. Are open. Let's roll. All right, so explaining how did we figure out this address? That really threw me for a loop. I apologize about that. When you wrote the reversing challenge and then you open it up and it is not what it's supposed to be, things get very confusing. Okay. Let's take a look at the graph. This is main in our reversing challenge. Here's the assembly. Of course, we can also look at this in what Binary Ninja calls high-level IL, which is basically a decompilation. If you click here to look at it in a list form, this is basically, C, right? Something very simple. So first, we do this stern comp between the first stern comp arg and the second stern comp arg of 3. And if that stern comp returns 0, which means the strings are equal, and you can look at the man page for stern comp to see how it works, then it gives us our flag. Very cool. Okay. You can see this isn't quite C. It has a bunch of weird stuff that's part of Binary Ninja's decompilation. But if we look at it in assembly, we can see what's actually going on on a memory level. When it says checking the received license key file, it takes this second stern comp arg, takes the first stern comp arg, and compares. The first stern comp arg comes from the stack, right? If we look at where else it's referenced here, where it's cleared out. It is referenced here where we load its effective address and mem copy it to somewhere. Where do we mem copy it? We mem copy something to it. Mem copy, if you look at the man page of mem copy, destination, and then source. So if we mem copy into this first stern comp arg, into the memory that's pointed to by it, from somewhere from the dereferenced RAX 3 bytes, right? So what are we copying in there? So RSI goes into RCX. Into RCX, we dereferenced RAX. So I'm going to demonstrate another feature of Binary Ninja. You can comment on here. You can say determined so far comes from RAX. Okay, now we need to figure out, right? So now you can comment this and build up some knowledge, track your notes basically. We dereferenced RAX. What was in RAX? It was something plus 8. That something was variable 28 RBP minus aux20, so something in our stack frame, and var 28, and we dereferenced that into RAX. Then so that is a pointer that we added 8 to and dereferenced this. So this now we can change the comment into something like actually we did dereference of, so we had a pointer on stack, we added 8 to it, and then we dereferenced it. And this is pointer on stack. Okay, now we figure out what is this pointer on stack. Pointer on stack got moved into RAX. Okay, pointer on stack is RSI. RSI is the second argument to main, which is argv. So this is argv. Okay, let's see where it's used. Here we dereference, add 8 to it. So that's argv1. And then dereference that. So this is argv1. And then we mem copy from argv1 into something pointed to, or into argv1. Dereference. We get argv, we add 8 to it. Then we read argv into, yeah, okay, so this is the value of in argv1, right? No, argv1. For sure, this is argv. Okay, and then we dereference argv. Then move it here to RSI. Okay, this is argv0, obviously, and then we say welcome to %s. So then it welcomes us to baby rev or so forth. Then we move. Sorry guys, I'm running out of steam after this whole class. Okay, we dereference argv. We get argv. We add a to it. So now we're pointing to the second argument in argv1. So as a reminder, for the stack layout, we got this. We added 8. That's the size of a pointer. We're looking at argv1 now. Okay. Everyone is on board. We dereference argv1 here. So let's comment dereference argv1. Into RCX. So we copy from argv1 I misnamed it. This isn't argv1. Okay. It all makes sense. This isn't argv1. This is our copied input. Phew. Okay, awesome. See, when you're reversing and you make a mistake, it can really mislead you for a long time. So our copied input gets stern comped against what's in RSI? This second stern comp arg. So let's rename it back to expected input. All right. We double click on that. It takes us to 4010, which has the value of OX 2008. Right now, this made no sense and it threw me off again. I didn't because I wrote this thing. I knew that that's where the string was supposed to be, but it's not. It is a pointer to the string. What kind of pointer is OX 2008? It is a pointer that will be fixed up using an elf relocation when the program is loaded into memory. So we go here. We can look at it in GDB. We start. Okay, we have a breakpoint. And now we can info proc map, see where the base is, and look at this plus OX 4010. And here it is patched up. So it is 2008 plus the base address of the binary. And that reads OIT. We can also look at the same thing in Binary Ninja. Here it's the address inside the ELF file of this expected input. Yeah. All right. And then if we scroll up to 2008, it's right here as well. So this is actually the same data that we were looking at in memory before it is loaded and relocated. All right. Someone asked, is the size of a pointer always 8? For the purposes of this class, yes. It will be on AMD 64, unless otherwise noted. There's a question on Twitch. Are we going to run CSE 466 next semester? CSE 466 runs once a year. pwn.college will be open all year, though. I don't know if we'll have time to do office hours, but we might look into it. Okay. Sorry about that grueling reversing combination of being very tired and unexpected error in my own reversing challenge. Let's check in on the ASU people. We got good memes. It looks like the channel of the day is Cycle. Everyone is on Cycle collaborating. Non-ASU, no one's collaborating non-ASU. What's going on? Yeah, we're regenerating challenges, and when they're ready, I'll re-show the what it's supposed to look like without the crater relocation. And this will also update. Okay, and it'll also update the Binary Ninja Cloud link. Okay, awesome. So let's look at level 1 teaching 1. Click inspect challenge. So we have regenerated the challenges to get rid of this insane relocation thing. We go to main. Of course, this is the teaching one. It has a lot of debug. But over here, it says it loads expected result into RSI, loads what I guess is our input into RDI. If I click here, boom. Expected result is 66, 63, 64. And that was DCF for my teaching challenge. No relocation. I'm really sorry about the relocation. It's a good thing to know, but it's a little too much of a very specific thing for this course. Connor just YOLO fixed it, but yeah. Yeah. That relocation was not intended. So if you are doing these challenges, reload. Teaching 1 is now fixed, and then Connor will announce as the other ones get regenerated. Sorry about that. It's okay. And we're also, Connor adds that we're having issues with level 7. You might only have a teaching 1 for level 7, but we're working on it. Oh yeah, and as part of that, the reason that level 7 right now is having issues is we have verification scripts that every single one of these generated challenges is run against. Every challenge is solvable. So if you're looking at a challenge and you say, I swear this challenge does not look solvable, it is solvable, we promise. I'm going to turn on the light so that I don't look. Oof. Boom. All right. Yeah, for those not on Zoom, it's got to look really weird when I pause to listen to to Connor just go blank and stare at the screen. So every challenge is solvable and is verified to be solvable as it's generated. So don't panic. Will we have ltrace? Shit, Connor, we should recompile again to fix ltrace. Alright, well, Connor prefers not to recompile yet again, so we do not have ltrace. But you can do the same thing with GDB, right? Let me show you the easy way to solve this. I just realized you go into practice mode. Or yeah, you don't even have to, but you drop into GDB, you break at stern comp, you run, of course abort, you run with some argument, ASDF, we're in stern comp, RDI is ASD, the first 3 letters of our ASDF, RSI is OIT, done, boom, which is more or less what ltrace does, well, in a different way. There we go. All right. Connor says ltrace is obsolete. No more ltrace. By the way, you can implement your own ltrace with LD preload, and it will work. Uh-oh. Hold on. I just lost audio because I ran out of batteries. That was... Am I online? Someone say something on Zoom. Yeah, now I can. Okay, perfect. Yes, if you want to explore LD preload stuff and see all the various weird, bizarre things you can accomplish with LD preload, I have a piece of software called Preeny. Preeny is a bunch of LD preload libraries that you can use for various things. I don't know if it's useful for this, honestly, but it messes with programs in all sorts of crazy ways, such as even turning network programs into standard in like normal command line programs, allowing you to patch programs, supporting like writes to file descriptor 0, other crazy stuff. Good stuff. All right, let's see how the collaborations are going. I was going to catch up on the memes, by the way. We're going to have some good memes for the meme review. Some good memes. All right, everyone should be working hard. There's only 0 in the collaboration channel for the world, but I guess this probably isn't a good time for worldwide people. All right. Any questions while we collaborate? Oh wait, did I stop sharing my screen on Twitch? When did this happen? On Zoom? When did this happen? So magnetic. Magnetic on Twitch is asking about this awesome piece of software. I think it's called IVC Tools. Wait, what? That's a new thing? That's... Oh, it's the same guy. Oh. Higher level than BCC? Oh, okay. So BPF trace is an awesome framework for tracing arbitrary syscalls and stuff in the kernel. Super awesome. Check this out. Completely useless for this assignment though, but very interesting if you're interested in introspecting and figuring out what's going on in the Linux kernel. Someone asked, how do you represent hex in the shell? You can do this. $, single quote, X, or single quote, X, 31, X31, X31. That's 111 in ASCII. Dude, I like this. There are people going live. So this guy's streaming IDA. This guy's streaming, or this person is streaming Binary Ninja. And the collaboration channels. That is great. Okay. Question on Discord will on Twitch. Will there ever be a casual hacking live stream where we can watch either you or Connor do some more advanced stuff? Not that we're planning. I wonder how it would. Maybe we can do like one CTF or something for a bonus CTF. No, we can't live stream a CTF. That's obvious. All right. Connor mentions on the chat he's talking about pony racing. It is a hacking race that's hosted online, and you can see commentators talk about it as people solve it live. Cool. What is this person streaming? Why is this not loading? Oh, that is Binary Ninja. Okay. All right. Any other questions on reversing while the students collaborate? Cool. Connor, have you done regenerating everything? Awesome. Can't believe it. Are you... Ah, there you go. I've been trying to convince Connor to use Parallel, the GNU Parallel tool. It's one of the most amazing ways to write code that is parallel. This tool. Oh, it's not installed. Do I have any guesses as to why modern game DRM like de novo slows down execution? A question on Twitch. Yeah, I do have some guesses. I haven't looked into de novo specifically. I'm more familiar with like DRM of like streaming media services. In order to protect itself from analysis and disabling, this modern DRM does insane things, right? For example, one thing that that some do, I don't know about de novo again, but one thing that these things do is implement virtual machine obfuscation. So that's slower. Any sort of obfuscation generally ends up with a slower execution time than unobfuscated code because it complicates the code. Virtual machine obfuscation with like interpreting a virtual machine bit of code is kind of even the worst case because it's suddenly slows down your native execution speed to something closer to an interpreter. I've seen DRM that jumps around in memory constantly. So it'll map itself somewhere in memory and then remap itself, unmap its old location and jump to the new one. So it's hard to follow around in memory and debug, but at the same time, all of this is overhead on the system. Some DRM uses hardware components, hardware capabilities to protect itself, right? But oftentimes those slow down execution. For example, there's some DRM now that runs on trusted coprocessors in like your phone, but this is slower. Or DRM that runs in SGX, a trusted enclave inside that can be created inside a program essentially that resists analysis. This is also slow. All of this has overhead. So kind of all the above. I don't know de novo specifically. I mean, modern DRM also, talks and grabs code off of the internet and downloads it, and runs that and constantly tries to verify itself to make sure nothing is, debugging it and so forth. It's quite a complex piece of software, and it can't just do its check once that the software is not pirated and then happily move on. This check has to occur constantly throughout execution. Otherwise, the fewer places you check, the easier it is to disable. And so all of this overhead gets paid over and over and over. which is very unfortunate because the result is that when you play a game that you legally purchased and so forth, you're in some senses getting a worse, or at least a worse performing experience than the pirates do, which is insane. But that's the society you live in. All right, let's check on the students. See, there's not a lot of people collaborating the collaboration hour. 1, 2, 3, 5, 6, 7, 8, 9, 10 in rest, about the same amount in cycle, and a bit less in sandwich. Someone's asking on Twitch, are you teaching a course lab on Zoom and also streaming on Twitch? Yes, that is exactly what's happening. It's a wild ride. This what you're watching right now is ASU's Computer Systems Security course. It's one of the required courses at ASU in order to get a cybersecurity specialization for your bachelor's. Otherwise, it's an elective for everyone else. And we are also streaming it on live on Twitch and open source the framework, or rather opened up the framework for everyone to use and so forth. Yeah, multitasking between this is tricky. But earlier today I was multitasking between 2 different meetings at the same time. Or was in class and a meeting. That was a fun thing. Connor was there. He was horrified. Question on Twitch, is the class junior or senior level? It is senior level. Some very advanced juniors take it too. But I wish it was earlier, so there was more time to pull these students into hacking, into security. Because otherwise, a lot of these the students here, you guys have 1 semester left, and then you're out. If you had like years left, maybe we should run this freshman year. Exactly. Is Binary Ninja down? Let's check. It's working for me. No, I lied. Okay, it's kind of working for me. I might be having trouble. Okay, well, it's a little slow, but not too bad. Yeah, we should have warned them that we were gonna start this weekend. That would have been or this week. Comment on Twitch. So many security courses are only on web security. Yeah, actually, we should probably have more web security material in this course. But there's just no time. I think if I added a couple more modules on web security, the students would rebel. Connor, remind me to write up some feedback from my initial experience. I think the biggest problem is that this rel. That's an. Yeah, why not show rip plus? Mm-hmm. Yeah. Yeah, no, but this is a very cool, the fact that you can just click and it opens in your browser. Yeah. Yeah. So I guess they show it because they know it's relative, but that seems more like a higher level analysis that should go into, their low level IL or something. I'm not sure. Binary Ninja Cloud is unresponsive for me at the moment. If I launch up level 1 testing 1 again, will it work properly? I mean, is it the new one? Okay. Good. There's 7 solves already, so I'm hoping that it is the correct one. Alright, well, this is fast. Maybe it was just that work. My guess is they have workers distributed on different servers, and one of the servers is dying. Oops. Testing 1, not teaching 1. Alright. Oh yeah. But okay, in this, here's the recompiled binary, and Magnetic is asking, it's not rip plus, it's relative to the relocation. In the recompiled binary, it is rip plus. So this is the exact, this is the exact the data relative to rip plus. In fact, if I obj dump it, let me SSH in. That's right. What was at that rip plus beforehand, what was at that rip plus was a relocated pointer. Now that rip plus just contains the data directly. If I SSH in and I obj dump -d, you don't have to use Binary Ninja Cloud. You can use obj dump or a number of other tools. There's a console based. Do we have Radar installed? No. You can install Radar. You can install a number of things to reverse engineer. Oh God. Okay, if we go and look at main, and specifically, we look at 1354. 1354. Here's our rip plus. Do I still have the old binary around? I do not. But the old binary was definitely rip plus as well. I mean, of course. So I have the like an hour ago. This one should work. Yeah, it's not coming up. I did not think of this problem, honestly. I feel really bad that we're DOSing them. Yeah. The nice thing, and there's a lot of other resources for decompilation. There's a question about level 8, Connor, on the Zoom. Permission of the socket is not writable for the user. Is that intended, or is level 8 broke? Good catch on Zoom. That might be a loophole in our testing. I think our testing runs in with more permissions. If you're looking into that, level 8 should be fixed shortly. Yeah, level 8, 0 solves. Level 7, 0 solves. Okay, people have made it to level 5. Connor, level 6 might have the same issue. Okay. Level 6 is correct, whoever was asking. Okay, question of how many levels total. There'll be about 15 levels. Yeah, Connor's slowly tracking down the issue. Those on Zoom can hear him. Otherwise, to update everyone on Twitch, permissions are hard. All right, we have 3 minutes left in the class, and I'll leave the collaboration voice channels and text channels running a little while longer. And I will, like I said, create a help channel that is always open. Where did it go? The hell? Oh, there it is. Okay. I've created the help channel. Now we need to desync the permissions so I don't turn off. How do I desync permissions? There we go. Perfect. Okay. Help will be always active. Binary Ninja back? Yes, this loaded. Okay. So what did you want to see, Connor? Oh, oops. Yeah, this is the old one. You want the input bytes or the instruction bytes? That'll give us. What now? So I'm pressing I. Why am I pressing I? Oh, I see. Okay, so for those that can't hear Connor on Zoom, I changes what level of analysis Binary Ninja displays up to this decompilation. Yeah, it does not resolve it. Crap. Yeah. Anything could happen. Binary Ninja vanished for a second. All right. So we've hit the end of the class section. Connor, another question about 6. How are we supposed to write to the named pipe if we do not have permissions to write? No. We'll look into 6. And we'll update you. So 6 and 8 have known issues. And 7, testing 1. Yeah, teaching 1 works. Testing 1 is questionable. 9 and 10 should be good to go. Awesome. All right. We're going to fix the challenges that are having issues. Again, the issues stem from the fact that we have a different permission model when we verify them. Then when we run them, we'll work on fixing that as well to avoid having this happen in the future. And then we will go on from there. 5 more levels. Something like 5 more levels will launch either tonight or tomorrow morning. Awesome stuff. Thank you for joining pwn.college. Don't forget, we have office hours. I'll hold office hours on Monday. Connor will hold office hours on Tuesday. Mine are 3 p.m. Monday. Connor's are 2 p.m. Tuesday. Next Wednesday, we will go into the awesome topic of memory corruption. And that's going to be awesome. And then after that, the week after, we're going to dive into this end-to-end combination of these topics. Stay tuned. See you next week.